All right. Hello and welcome. Good evening from us. Good morning to some of you. Probably a lot of you watching on repeat. Good day. Really lucky to be here with Dael from Databricks. So thank you very much. Another Databricks stream we have coming on. So really thank you for being here. I'd love for you to introduce yourself and say hello to everyone.
Thank you, and thanks, Steve. Yeah, great to be here. So I'm Dael Williamson. I am EMEA Field CTO at Databricks. And yeah, it's going to be fun to kind of have a chat to you today.
Yeah, really looking forward to the topic. I think definitely is close, something to my heart. I do a lot in governance and all of that kind of stuff. So very interested to hear what you have to say. You are based over here in the UK, I believe, as well.
I do. Yep. I'm in London, enjoying the ridiculously warm summer, which is kind of abnormal. I'm Zimbabwean, and I'm complaining about London summers, which is very strange. I think it's the humidity. The humidity gets me. We have dry heat. This is different.
Yes.
But yeah, and then I cover most of the EMEA, which means I'm literally normally living on a plane. My joke with my family is during the summer I'm at home, and during the rest of the year I live at Heathrow Terminal 5.
Excellent. Yeah. No. Lots of travel. We get that. Sounds good though. Sounds very exciting. How long have you been at Databricks yourself?
Coming on 5 years now. So I joined, I think we started chatting about 5 years ago about me moving over. And then there was a sort of transition in. One of the reasons for setting up the CTO office is like Databricks at the time was very good at the sort of bottom up, where the practitioner's choice, very popular with hands-on practitioners. And we needed people that had hands-on practitioner depth, but also knew the ins and outs of leading large, massive organizations. And I came from the buyer side, so I was a buyer, and then I was on the consulting side. So coming over was very fun. And my whole thing has always been trying to figure out how to do the more executive education, but also I'm a scientist. So Databricks actually has a lot of really cool academics that work there. So you kind of feel like you're with your people.
Yeah, I see a lot in the sort of data technology industry come from lots of different interesting backgrounds, sort of science, engineering. I think it makes kind of a natural curiosity, like the logics of stuff. So yeah, see a lot of that. And we've been using Databricks a lot. We use it a lot here at Analytic Endeavors. Before that, me and my team, big users. I think I've seen a lot come in the last few years. Quite a lot of growth, quite a lot of directional changes in terms of not changes, but additions, I might say, in what you're offering as well.
Yeah. I think we were quite lucky because we're always the data and AI business, but for us AI was sort of more complex machine learning. So we had like an in-depth community that loved MLflow, loved doing a lot of classical ML. I myself am a proteomics biochemist, so I used to spend quite a chunk of time. This was pre-AlphaGo, which made the job much harder. You're always doing hyperparameterization. You're always kind of building models. You spend more of your time shopping for data and like just finding, making, building, creating. So I think we were quite lucky because we had that community, and that community naturally gravitated over to transformers as they started to become more popular. One of the things that's kind of cool about Databricks is kind of AI blending. We actually blend a lot of different sort of AI techniques. and the velocity of the product is also because we're using it in the company. We actually use it quite a lot. Everyone's kind of given a charter to hack their jobs and to kind of like do a lot more with a lot sort of more tooling. So it's kind of cool. We're given like a fair degree of license to do that.
Awesome.
But yeah, the ship rate is actually quite relentless. I mean, in a role like mine, you can only imagine. I have to almost know exactly what's coming, and I have to be able to explain it. I have to be able to translate it, and the velocity is just like at another level.
Yeah, and a very quickly changing industry and field that we're talking about now. I think AI, if you mentioned that 5 years ago, as you said, very different to what people think of now, and especially at a C level and all the stuff that comes around with that. But yeah, I mean, you know, we've been big fans of Spark, and I remember seeing a lot of stuff about kind of lake architecture before, you know, it was really that popular. And now I think it's one of the biggest patterns we implement for good reason. So I think that as well has become kind of a go-to for a lot of people. And obviously AI sits quite well on top of that.
Well, I think it's more than that. Like, I think like we keep moving adjacent, right? So like Spark solved the problem, and then Delta solved another problem, and blending Delta and Iceberg solved another problem. Unity Catalog solves a completely different, like almost profound problem. Extending Unity Catalog to cover more assets and things like that, even bigger problems. But we've never stopped kind of and just rested on our laurels in the data space. You know, Lakebase is probably one of the fundamental reasons I actually joined the company, this idea of kind of joining these two worlds. Because I was a full stack app dev guy as well as, you know, studying biochemistry. When you study biochemistry, everything's really slow. And when you're in research, you kind of like run these simulations, and they took like, this is in the sort of late 90s, 2000s. So I'm kind of showing my age a little. So I started my career in 96 on a mainframe, and I very quickly jumped onto the Unix movement. But in parallel, you're building simulations, and they take like 45 to 185 days to build a protein model and then run screens and simulations on them to figure out if, you know, like a drug target is correct. And that takes an additional ridiculous amount of time. So you got to kind of eat. So I had a full stack software engineering kind of pathway. So I had these two worlds long before I decided to move into management. And it was like loads of fun. It was probably a good, you know, almost 2 decades that I did that. And like knowing intimately like that this has caused organizations to be completely divided and to create these like ultimate silos. Do you know that there are like 434 databases that exist on the market today?
Doesn't surprise me. Yeah.
So there's like a ranking called DB ranking. And like, there's another way of framing that. If you're an executive or you're a business, you know, person, what you're effectively doing is copying and pasting data from one thing to another, to another, to another. And then you have to check it again and again and again and again. So you've got this integrity tax, and you have this time tax of copying and pasting. There are some organizations that if you want to go from like a point of sale system, like I was chatting to a kind of an oil and gas company, they were explaining this to me, like they have garages where you go fill up your car, and then they have where they record the cash in the accounting system. That takes 7 days. And there's absolutely no viable reason why it takes 7 days, except for it needs to be copied to here, checked, copied to here, checked, and those are overnight batch jobs. So like this is the kind of stuff that I spend my time with, which is why like the topic, the theme that I speak about is how AI is changing company structures and dynamics. But the reality is it's not just AI, it's kind of how data, how tech, you know, you start to see structural changes. You start to see how roles are becoming kind of blended. Like even 5 years ago, think about it. We had data engineers, we had product managers, we had software engineers, we had data scientists, we had like business analysts and data analysts. Now you could have a team where they might have been one of those people 5 years ago, but they're all of those people today because they don't actually have the limitations, like to build, to analyze, to build a PRD. There's new limitations. Don't get me wrong, but it means that kind of roles have become soup. And that's hard because that's a structural change. I reckon that's going to happen in every domain, in every company.
Yeah, and I think hard to manage from an organizational point of view, or at least hard to keep up with, I'd say. I mean, the amount of new roles and new names of roles that I've seen on stuff in the last few years also can be quite intimidating, I think, as people who have been sort of these analysts and all of that for so long. Although I think quite a lot of opportunity. You get to suddenly you're an engineer as well, and all of this. So interesting to keep up with. And I'm sure some of this we'll talk through today, and then those kind of roles and how everything's changing.
For sure.
So I think with that, I think this is good to kind of transition, and we can pull up some slides, have a chat.
Yeah, so the way that I've structured this is I've got like little blocks, and there's going to be a kind of screen that shows up that says any questions at some point when I finish the block. So I'll try to make it through quickly through each block. And then, Steve, if you have any questions, and then I can just move on if there are no questions. So this is a talk I've been doing for quite some time. I've had to iterate because stuff changes quite regularly. It's part of a research study that a little group of us within Databricks started about almost 3 years ago now, which is how the structural change, how AI is impacting company structures and dynamics. Now, we often, technologists often think about the technical system, but what's kind of cool about organizations is they are a system in their own right. And as a biologist, if I were to equate it to a living system, it'd be like that sloth in those movies where it moves really slowly relative to how amazing things are in a human body or in a natural system. So like complex systems is where I really spend a lot of my time. And I'll get to how I've really enjoyed some of the data that I get to explore. So this is not based on this. A lot of this is grounded in empirical research. And the whole basis of it was what happens when an individual contributor who's got no management experience suddenly has to manage a swarm, a fleet, whatever the collective noun is, maybe a fleet with swarms of a variety of different AI agents maybe, or other kind of tooling automation software, where suddenly they're able to do a lot more with their time, and that leads to a whole different set of problems. And I'll talk about some of those. So that's the thesis, that's the hypothesis. And it starts always with AI is very cool. But the reality is that like we have these cool point solutions, but they're very point solutions. They're very middle to middle, they're not very end to end. And these ones that I've put up here, scaling RNA, this one, single cell models to identify drug targets. Our CEO loves talking about this. It's a model that was trained on RNA. It proves the scaling laws. It's an incredible diagnostic tool, but it's a very specific point solution, massive potential. It can sort of aim to compress the R&D drug phase. Ironically, when a drug company takes a new drug to market, from the identification to the point in which they're ready to like show ROI is about 13 years. That's a 13-year horizon. Most of those drug targets are probabilistic in nature. My little joke is, how are they afforded 13 years for ROI and for a probabilistic system where AI is already wanting ROI in 3 years? But let's move past that little thing. I like to then baseline. Actually, what's the real state? So this is Databricks in a box. So we're this sort of enterprise engine, but a lot of people don't realize we process loads of data, and we do that across all agents. So that's about 150 trillion tokens a month. It's also 50 million virtual machines a day, and that's across 70% of the Fortune 500. All of that data goes into our internal Databricks. Our internal Databricks, and when I say data, I'm talking about telemetry. I'm talking about like trace logs and stuff like that. I'm not talking about actual customer data. Customer data sits in customers' tenants. We have no visibility of it. The usage, similar to like how when you use electricity, in your house, there's usage behavior. So your electric company can tell you when to charge your EV or run your washing machine. Databricks has this logging and telemetry data. A lot of it comes from the cloud providers, and a lot of it comes from other mechanisms that we've developed to look at it. And it's super important. It's like IoT. We need it to be able to do maintenance. We need it to be able to guarantee uptime. We need it to be able to improve the quality of service. So there's a necessary part to it. But what's also cool is it's a very cool corpus of data. So one of the things that I've come to realize, and I actually went and did an analysis recently. So if you take the average enterprise, flippantly, let's say 100% of all enterprises are doing some form of experimentation on AI. And that could mean somebody switched on ChatGPT once. So let's just assume that is 100%. Because by now, I think it's pretty close to being 100%. Someone in some enterprise has flipped the switch and made it 100%, even if they don't have an AI program. 10% of those make it to production. That's an average. Some stats say 5% make it. Other stats say 20% make it. I think that's relative to the industry. It's relative to a whole bunch of things. But actually, the survival rate is very low. I've been kind of kind here and said it's 3%. By my latest analysis, which was a couple of weeks ago for one of the big universities here in the UK, it's about 2.4%. So that's if you were to think about it, that's 2.4% of use cases in every 100 stays in production. Now, that is a structural change that companies need to go through to figure out how to keep these models in production. I like to joke that it's a bit more like building a flight traffic control center than building an IT services function. So there's a very, very big difference in how those two functions or capabilities within a company operate. And we have not figured out how to do it. Even the AI natives are learning this, if some of the dramas of the last week are to go by. So there's a lot of how do we manage, how do we monitor, how do we govern, how do we make sure the flight paths are right? And that's a really interesting kind of statistic, which tells us that we have a lot of work to do before this stuff actually is going to scale. I have a personal agentic experiment that I ran on the 1st of March until about the 8th of June. I ran this experiment, time-boxed, because you've got to time-box things. And the reason I did it during that period of time was because that was a very active travel and expenses time. So if you looked at my travel and expenses data and you compared it to this, you'd be like, how the hell are you doing these two things at the same time? Because I went to multiple countries. Some of them were long haul, and I somehow managed to, during that time period, process 43.1 billion tokens. If you paid retail rates for that, it would be about 35,250. Now, before you kind of call me a token maxer, in 640 business hours, I did 9,195 hours of work. So I don't really regard the kind of token maxing side. Everything I built was very useful. Some of it was slop, but I learned something from every sloppy thing I built. A lot of it was stuff I use every day, like still every day. And even before coming on here, I was building a few bits and pieces to refine something I built a little while ago. I have 9 non-humans that work for me. They're not agents. They have an average of 8.4 agents each. That actually has grown. And I'm the tiredest I've ever been in my life. I'm also the happiest I've ever been in my life, because it's kind of fun. It's like when I was like sort of coming up in the world, you could code. And then I was also working with proteins. So it's like having those 2 jobs at the same time. But what it means is that an executive no longer has to have the trade-off of only going out and being in meetings and then coming in and actually chatting to the teams about how things actually work. They can experiment continuously while doing their job. I've sat in events with my laptop open. This is a little meme that I always throw out because it's quite funny. But one of the key observations I have, and anyone who's not international might not get the joke, but there's a comedian out here called Michael McIntyre, and he always talks about parents and non-parents. Parents will also get the joke. Non-parents might not get the joke. So he talks about how hard it is to leave the house and how parents know how hard it is to leave the house and non-parents don't know how hard it is to leave the house. I've got 2 kids. You always have to have a degree of buffer. I tend to go back into the house. Like this morning, I had to go back into the house because there was a toy. 2 days ago, I had to go back in the house 3 times because something was forgotten. When you build with AI and you use agents to help you with your job, it's like being a parent. And I can tell non-parents from a mile away, in the same way as I can tell others from a mile away. So this is actually what's starting to happen. If you're a practitioner, you probably get this. If you're an executive, you probably have no idea what I'm talking about. But you say a lot of things that sound AI, like sound smart because you've read like a BCG book. But you have to play. And that's kind of important because this is going to fundamentally change the way we manage. Mark Andreessen did this really cool thing the other day where he kind of talked about the Unix mindset. But he talked about how agents slap this on. Now, I'm showing my age here, but like in the 90s, we had shell, file system, markdown, cron. Those were our tools. And we had that on Unix, and then we shifted them onto LAMP stacks and things. We didn't have Git. We didn't have testing. We didn't have all of the things we take for granted today. None of that stuff we had. So we had to make all of that stuff. And I think that this is one of the funnest times because we're having to make all this stuff again, but we can do it really fast. This is what I've kind of learned over the last few months. Software is super cheap to create. Testing is harder than anything I've done before. So I have 11,000 system tests that run on my code base. I have evals that run on my code base. I check for drift. I have lints. I have all sorts of things, and I still have bugs. So like it is, and I consider myself a reasonably good coder. I'm dying of judgment overload. So AI burnout's a thing. I'm biohacking myself back to normal. If you want to talk about that, that's kind of fun. It's got to do with the glutathione receptors, and I'm taking I have a whole regime, and like people in my company are actually copying me now. Telemetry and trace are like the most important things. Like I capture all my trace logs, all my session trace, all that stuff. I harvest it. I use it for recursive self-improvement loops and all of that stuff. OSS models are key. Now, it's funny. When I first made this claim, it was September last year. this now, because of Kimi 3, is kind of like duh. But as a company, Databricks has been monitoring the open and foundation world and sort of hedging for quite some time. If you look at our AI gateway, which processes 150 trillion tokens a month, there are multiple models that you can run through that. And there's a lot of US open source models coming into the mix now. So this is going to become a big deal, learning how to do this sort of aspect and linking between C and B, so telemetry and trace back to small models, telemetry and trace back to small models using your test harness, and then open orchestration. And that was sort of the OpenClaw movement. So this has been the funnest thing to kind of learn the structural pieces that make sense. And this might just be the beginning. We don't know. The exact same thing happened in the early 2000s. We started to invent new things. Databricks launched a meta harness to link harnesses together, because it actually turns out that is a really important thing. And big plug for going and downloading the open source Omnigent and having a play around, because it sort of makes that whole laptop keeping it open thing go away. So that's a whole initial point that kind of sets the scene. Any questions?
I have a couple myself. So I was quite intrigued by your slide here in your research about only 3% of those really making it all the way. Interested to hear if you have any.
10% make it all the way.
10%
survive.
3% survive. Yeah. Sorry. So out of the 90% that they go to production and the 3% survive, I'm interested if you have any thoughts or idea on what kind of the key things that kill those. I mean, do you see it as a technical problem, a governance problem?
So deliberately, I've gone into digging into like each of those. The sample size is actually quite large, because if you take 2.4% of all AI use cases across 22,000 customers, that actually gives you a pretty big sample size. Cost is a big one. So cost, massive problem. Stability and quality, huge problems. So like, for example, you might spend a lot of time getting the model to getting the AI system to production. And what you might find is drift happens relatively quickly because of the use case, or because you haven't done enough loops, or because your proportion of model to system is a little skew. We've actually worked out for every $1 of model spend, you're looking at $27 of scaffolding spend. And I say scaffolding because I'm saying data, governance layers. Governance is tricky to quantify because we don't charge for our governance layer, but it is like we do find that if you have anchored this with really solid governance, you're 12 times more likely to keep it in production. A lot of it has to do with skills. So does that organization have the skills to sustain it? Does it have the capability to monitor and kind of look after and evolve and upgrade? Because this is not like a mainframe where you write it and then shove it in a corner and 40 years later the thing still works. This is it moves around. So the reasons are variable. And there are clusters of groups that they fall into. But it is a fascinating problem. If you start to find that your ratio is heavily weighted, so let's say the system is proportionately more model than like surrounding scaffolding, you'll find the chances are it won't survive. The survival rate is very low. If you find that you've put a lot of testing, a lot of evals, you've proportionately governed it well, you've proportionately monitored it well, you've really thought through the domain stuff, you've balanced it with sort of harness characteristics and other deterministic code, the thing will sustain much better. You still will have to do some degree of kind of recalibration. But this is like a new skill. We're learning a new skill. So anyone talking about, like, this is a whole new job class that has to come into the market. And it's cool. I mean, it's the evolution of QA.
Interesting point. And you know, I think you talk a lot with the Fortune 500 and some of those bigger companies. I see this a lot with smaller and mid-sized companies as well, where they traditionally maybe haven't had a lot of that sort of dedicated roles to testing and all of that stuff, and have a lot of people now who didn't really know how to code and all of a sudden are building stuff. Do you have any sort of thoughts on advice on that testing layer that I think some people maybe haven't really had a lot of exposure to, or really done much official and testing kind of stuff before?
Yeah, I mean, I do this all the time. I'm like ultimately looking up who's created different open source testing layers. I mean, I did an analysis the other day on it because I need to improve my sort of testing structure. So I think we're kind of at the beginning of this. So there's probably some companies that are doing a pretty good job of leading the way. But I think this is a pretty huge area where it's not quite as crowded as people think. It's not quite as mature as people may believe. There's a lot of stuff a lot of breakthroughs that are not, like they're good for one sort of thing, but they're not good for another. So we have to develop these. I'd say most people that are getting into coding, because I think coding will diffuse into more people. You know, the amount of people I know that are using tools like Claude Code and Genie Code, and other tools like that are like quite profound. They're starting to realize they have to test stuff, and then they start to ask, how can I test stuff? I'd always say that one of the things we've realized is if you build with model A and you test with model B, that's kind of useful. But there's a whole bunch of new frameworks, similar to like in the early 2000s, Chef and Puppet took a long time to come to the market. They were the initial OGs of CI/CD. It took us a very long time to get to the Phoenix project and the whole DevOps movement. I think that will go through the same thing. So my advice is, we have very, very good ways of researching every month. You could just literally open Gemini and do a screen every month. You can open whatever your poison is every month. Do a screen of what tests have been created, what new frameworks. You can even build a skill that analyzes that on a monthly basis in a cron job or a schedule. So, yeah, this is fairly white space, and the opportunities to kind of just build and then learn is endless. We're now in the loop phase. Everyone's talking about loops. Like we've been in the loop phase before. It's not a new thing. We always, like a lot of the stuff. I always say go back to the 90s, go back to the 70s. You'll find stuff that like is actually really useful today. So I do this all the time. I kind of go backwards and then I look at what's out there. But yeah, that's my advice. Yeah. Is just play.
Awesome.
Let me jump into the next section just to kind of keep things going. So there's a bunch of things that we actually do see that have changed. We don't actually see as big a change as people realize, much to the 2.4% success rate. So in engineering, we know this has changed. Databricks has 2,000 engineers building the platform and 3,500 field engineers. And all of us have access to lots of different tools. And we're very promiscuous. We use all of them. And we sometimes use multiple of them on the same day. I've used 3 harnesses and 4 different, underlying models today. And that was just this morning building a few things. So so we used to write code, and then today it's about review. it's the bottleneck now sits with reviewing, quality assurance, and all of this. And now we're building new things to do the testing, and we get back to testing. You know, GitHub has problems every like pretty much in the UK, every Saturday afternoon, like late afternoon, GitHub crashes, and there's all sorts of dramas with GitHub. That's not a criticism of GitHub. It's just an observation of the scale. We sort of see the same thing happening in security. Security is bonkers at the moment. Databricks launched a new product called LakeWatch, and this is because we see a huge transition in security where, you know, agents are doing an incredible amount of the work. Before, humans used to do a lot of this analyzing alerts. Agents now do hundreds of thousands of alerts per hour, and humans just deal with the escalations. Risk management. Risk management is one of my favorite areas. I don't know why, I just love risk management. I think it's got to do with the kind of science that goes behind it, the chaos, the unknown unknowns, that sort of thing. But I've worked with risk management and risk-like teams across the world in different industries. Before 2024, as a consequence of 2008, actually, so between 2008 and 2024, you would need an army of about 2,000 engineers. You'd be outsourcing, you'd be offshoring, you'd have huge amounts of domain experience mixed with people building these things. I know of a risk system that just tested firm-wide risk across a large investment banking firm, and it tested credit risk. And that system was 2,000 engineers and cost around about $400 million to build over a 10-year period between 2008 and 2018. And you could run it once a year. Okay. Now we run hundreds of stress models a week. Jamie Dimon was on our stage. He actually testified to the whole idea that, like, he doesn't care about CICA. CICA is a regulation that the Fed apply to financial services firms to run risk simulations and to run liquidity simulations to determine their exposure and to determine whether they can survive. He runs them hundreds of times a week. So we put that to a test because we were like, okay, well, most people read that and say, well, JPMC has lots of money. We applied it to supply chains last summer. Okay, so this is already a year old when we did this, almost exactly, just over a year old. We took some maths from MIT and we applied it to stress testing supply chains. The simulation we were able to run, 38 minutes for $1. Okay, this was 3 engineers. We built this in 20 hours. The data part takes for ages, way longer than 20 hours. This application that we built, so this kind of scaffolding, it runs on all 3 hyperscalers, so you can port it between them. And it basically allows you to, and it was built by 3 engineers in a very, very short space of time. They're very good engineers, just to be clear. But this tells you that you can build some unimaginably impressive stuff with a very small team. We then thought, okay, well, supply chain managers can't really understand the complex maths of Monte Carlo simulations. So how about we build a reasoning agent on top? We actually built 5 reasoning agents on top that did a whole lot of the work to help sort of facilitate. That was 2 engineers, 8 hours. We've open sourced all of this, by the way. So if you kind of look my name up on Databricks and you go look at some of the blogs that have been published, all of this is open source code. So we then took another section to stabilize, because the thing is, you could be giving, like, a supply chain manager loads of advice. And if it's not anchored in the reality of the contract you have with that supplier, so let's assume, you know, a ship gets caught in a strait and the supply of whatever that good is going to be very, very difficult to fulfill. You would want to switch suppliers if you could. And you would want to know, can I switch suppliers contractually? You know, and what would it mean to switch suppliers? So basically, we built an AI search that is such a cool feature, because it basically allows you to take unstructured documents and then link them into your system. Nobody could build stuff like this even 10 years ago. So this is an insane application. 2 engineers, 15 hours. So that's like 3 sprints, really. And a very short space of time, we built something that was unbuildable before. And this was about a year ago. We've started to scale this across different market groups. And that's what's changed. So that means that if you're running engineering teams, if you're running risk teams, if you're building software for like a variety of different business domains that have structure, okay, structure's key. Like if they're a chaotic space, where it's very complex, like sales, like marketing, that's very complex. And the reason it's complex is just because of the sheer veracity of unknowns on activities people do. But if you're in an area which has some structure to it, because there's compliance, there's legal contracts and things like that, it's much easier. So anyway, that's a really cool segue to kind of just talk through, any questions. Like these are the mad things that we sort of seeing in how to build teams, how to build software, and the type of thing you can build. This is mixing old school, statistical models and Monte Carlo models and predictive models and like mixing it with generative. So you're building an entire new application layer. It's like kind of a new form of 3-tier architecture.
Yeah, it's really, really interesting, I think. I think we all know AI can do some pretty powerful stuff, but it's very interesting and still amazing to hear some of the stats there. I think, one thing from me is you always say, you've got these good engineers who can build this. Do you think there's kind of key skills you have and need as you would look for in a team? To me, it's always, people talk, the vibe coding and stuff. So I always think of vibe coding as those people who are doing this, but don't have those sort of other skills of some of the testing and other things you have.
Okay, I'm a scientist. Mm-hmm. The skills that I use in science, the scientific method, form a hypothesis, mm-hmm. develop a set of methods to test the hypothesis, do my research to understand what's been done before. And so you always have like this structural way of working, run some tests, generate results, conclude, go back to the beginning, go again. One of the things that science teaches you is the art of failure and getting up and moving again. The similar skill is found in entrepreneurs and founders. This ability to kind of try something, pivot, try something, pivot, try something, pivot. So that's probably a primary skill people need, is this kind of curiosity and this ability to be quite methodical about how you work, but also be a little bit sort of okay with ambiguity. Because right now there is limited structure. Most people want to buy this and for it to work. That is not going to happen. So I think there's those kind of skills. Mathematicians do insanely well here. Finance people do insanely well. Like people who are used to working with Excel are now finding a new form of like just amazing things. Lawyers are actually pretty good at this. Like that's why Harvey and Lagora are such big AI companies, because lawyers have that kind of attention to detail, that critical eye on like writing up contracts and, drawing up things and, making sure that they've checked everything. Actuaries will be good at this. So there's a hell of a lot of analytical roles and there's a hell of a lot of creative roles. But I think the cool thing here is it's about the fact that all the limitations we used to have. Like if somebody said to me 20 years ago, can you build what I just showed you? I probably would have gone, well, we can try, but it's going to cost a hell of a lot of money and I'm going to need a lot of people. Like, I think you could get away with a very small team. And I think over time, a lot of these skills will start to diffuse. And there'll be abstractions that build more structure. And we're already sort of seeing that. But yeah, I mean, I don't think that this is such a quantum leap to be able to get there.
Awesome. Thank you.
Cool. So I've got another couple of sections. So let's talk about failure modes. Okay, so this is kind of more organizational. So the first failure mode, like there's 5 key ones. Models are smart, but they don't understand your company. Now, that's obvious. Companies have their own language. Okay, they have their own structure. They have their own org charts. They have their own way of doing business. They have their own flow. No company is exactly the same as another company, even if they're in the same sector. They're very, very different. I have worked with thousands of companies across the world. They are very different. That's why when you change companies, there's an onboarding period. And it takes often a human at least a year to 2 years, even if they have deep domain experience in what they're doing. It can take them, a year to 2 years to really, really know how the structure of the company works. And people that have been there forever, they lack the diversity of how other companies work and how something could be improved. So models are like the same thing. Software wasn't built for agents. That's kind of funny. I'll get to that in a little bit. Silos and lock-in, this is a huge, big problem. People are arguably it's going to be one of the biggest challenges for transformation, and governance and security. If you don't have that kind of sorted out, it slows you down. So the first section, that sort of this idea of it's not about the model, how do you make this work? It turns out that actually proprietary data and a variety of proprietary data is super, super important. So if you have a unified pane of glass, you are able to manage transactional data, you're able to manage all that unstructured, sort of vectorized embedded stuff. You're able to sort of build time series databases, and you're able to create telemetry and these loops. If you can build a platform that facilitates this, that also allows you to own your models, your IP, and to own your data, that's the kind of key. And it turns out that is our value proposition. It's a big, big area of sort of helping to navigate, like reducing the 434 different proprietary databases. So that's the kind of big one as to how do you get a model to get to work better within your company. You have to bring the model to your data. And remember, I said for every $1 of model spend, there's about $27, and a big proportion of it is your data. IP is a big question that people have to start thinking about. Like, are you the product, or are you building something fundamentally valuable? The second thing is kind of profound. So a year ago, if you'd asked me, most people working with Databricks would have been hand coding. That number is now 6% of our total usage. It's baffling. Now, it was quite cool because Databricks, initially, we had a lot of IDE users and we had a lot of notebook users. So we had to build very good CLI, very good APIs in order for the IDEs to be able to work with Databricks. Actually, it turns out that was really useful because agents love those and they work really well with those sort of CLI and API kind of tools. You need 2 design surfaces for your software. The design surface for humans is UX. It's the UI. It's the pretty screen. It's the ergonomically pleasing and filtered thing. If you have to deal with way too much volume of content, you are going to your brain just degrades. Agents don't care. They actually want more context. So if they have to use the human UI, you're going to burn a lot of tokens. And that basically becomes a churn problem because your software no longer works in the way you need it to work. You could probably stopgap it for a period of time with an MCP server, but that's not going to last long. The need to use that at scale and hammer the hell out of it, there will need to be a kind of reconciliation as to how you re-platform. And it'll happen, platform by platform. There's going to be competition across the board. Any company that thinks they have a monopoly in a particular software domain, they're going to have massive competition in the next 12 to 18 months. That's inevitable. The third problem is a very fascinating one. It's this idea of the process illusion. So management thinks processes follow a straight line, okay? Sometimes they're slow, sometimes they're fast. But actually the reality, especially in knowledge work and especially in business domains, is it is a very messy set of activities that follows that straight line. So underneath follows the straight line. This is actually being written up called the garbage can theory. Now, one of the coolest things, we work with a company called Celonis that analyzes that messy spaghetti ball at the bottom, and they pull up and they can tell you basically how your process really works. They originate out of process mining as a technology. They run on Databricks, and they're one of our big partners for kind of doing this. The context they pull is how work happens. The context we run is how work is sort of like how the sort of data flows go and how agents are working. So you got this kind of combinatory thing. Now you have to like this, the detail is super key. You have to get into the detail as to how things really work. So this is a big problem to solve. Coordination overhead is the silent killer of organizations. The funniest thing about most companies is they have some degree of hierarchical structure in the way they work. And that requires a lot of alignment meetings and manual reviews and a whole lot of management theater that tends to take place. When you build agentic systems and you build it like the sloth on the left, they're very inefficient. They actually tend to, they do need some oversight, but they tend to work very well in a network formation. And I think we need to kind of figure out what is the management dynamics of the of the network, and this, how do you build this into a living ecosystem, and take inspiration from things like birds who don't crash. And birds are quite amazing to watch them fly. Like, how do we get agents working like that? How do we get humans plus agents working like that? That's a very big question. Not a lot has been done here. We also know that I've mentioned this before, governance and strong governance means 12 times faster. The quality control problem is a big problem. Legacy is your biggest problem. So legacy is a problem because of the design surfaces. It's got the UIs that are not very easy to navigate, but it's also the problem because there's a huge amount of locked in context that you can't get access to. And there's an entire new sort of economic framework around these things. So cool. Any questions?
No, not on this one, I think. No, I find it very interesting what you said, and on, I always say technology, I think always moves very quick. I think that's sort of one of the easiest parts to implement. Org structures, governance, all of that tends to move a lot slower in my experience, and I think it's going to see those leaders and companies looking to try and keep up with the technology in that kind of non-technical part. It sounds like is going to be where a lot of success drives. Which isn't always easy for companies.
Huge challenge. Cool. So then I'll go to what are the successful ones actually doing? So there's this really cool movement. So on the left-hand side of this, it's that whole AI gap I spoke about, which gets us to a very small number of successes. The cool organizations that I watch doing things it's a very fascinating thing. The first thing is they're starting to build like maps and optimizations and simulations of organizational structures. Like, one could argue like it's similar to the digital twins that we were building for buildings, but they're building it for org structures. So organizational digital twin, call it that. The idea that data is an intellectual property, it is something of an asset that you need to catalog, you need to register. People have lists of financial assets, they have lists of physical assets for their companies. Those are disclosed on their annual reports, their balance sheets. They do not actually have a really good inventory and like setup of what data they have, where it originates, why it might be valuable. And they're not even entirely sure how to mine it appropriately. So that's an entire new function. So remember I said there's a new function making AI work. There's another new function that is like almost doing the corporate archaeology of the company. And then I'm being polite here when I go from silos to unified teams. This is almost like the soup of roles that we talked about earlier, where like you had a specific role in a specific team in a specific function, and now everyone's doing everyone else's job. And we have to figure out, what does that look like? We used to do this in cross-functional agile teams in the early days of like where agile was actually kicking off, and you could kind of build high velocity teams. This was during the 2010s. As automated testing came about, you would build these cross-functional teams. And the reason you did that was to get maximal velocity. So I think we're going to move to that, and we're going to stop with the specialization and move to a far more generalized skill base. But we don't actually know what these teams are going to look like. There is a fundamental change to the build and buy equation. Buying AI, that is not an AI strategy. It's good for individual productivity. It's good to kind of get people going. It's actually kind of weird. Like historically, the genesis of a new problem led to us building something to solve the problem. Then products would emerge that we would buy, and then it would form into utility. Actually, all of that is switched around. So nowadays, what we're doing is we're buying something so that we can get started, and then we start to think about how do we build it, and then we start to figure out what utilities can we build on. And that's a very fascinating change in mindset. So build AI is going to be where transformational execution happens, but it's not like full stack build. And we're sort of seeing this already. We're sort of seeing companies like these ones building so that they can be model promiscuous, they can connect to all their data. They have a very different structure of how they build. Everybody is now focused, well, I wouldn't say everybody, but all the big labs, all the sort of AI natives, all of the digital natives are starting to recognize how important telemetry is, how important it is to be able to understand what people are doing, prompts, what's happening within the prompts, what's happening within the model-to-model interactions, agent to agent. There's a huge amount of logging and monitoring that we have to do. We've gone through this kind of evolution of software, and we're in now the work layer of software. And most of us have no idea what that looks like, because we've always taken it for granted that stuff just configured within, some SaaS product, and then we'd start working. It turns out that's actually where the real essence is. And like, it's a very, very difficult thing for people to actually know what is our work logic. And then this leads us to the final sort of point. Buying behavior. So if you're an executive and you're buying software, your software needs to go through a whole new filter. Does it lock me in? How does it lock me in? Can I keep lock-in to a minimum? Is it portable? Can I move from one cloud to another in order to arbitrage? Can I move from one model to another if this model's better? Do I have, especially here in Europe, glass box in order to explain and meet regulations and almost kind of have that degree of transparency? Headless, because agents don't like user interfaces, and footless, because you need that kind of flow of context and data. Like, that's super key. If you don't have that flow of data and context, and when I don't mean copying it, I mean it's got to be readable wherever these agents work. They need to be able to call things. It's like extreme APIs, but APIs not in the same way as the historical way. So there's a huge amount of exchange that has to happen, and it's got to be also just in time. This kind of shared memory idea. So everybody is trying to think through, how should I buy? How should I build? And this is one of the most common questions I get from executives, is what has happened to the build and buy? Like, how should I be thinking about this? And that's basically me.
Awesome. No, I think that was very, very interesting. Lots, I think, going on. It sounds like there's going to be a lot of A lot of new thinking. I think when you talk about organizations need to change, as we said, that's something not all organizations are doing in terms of structure and that. So I think it's going to be a very interesting time and see how this evolves. I do say from a technical point of view, I think some of the stuff you said was quite reassuring in my mind, especially, a lot of these skills that you need. It's not like we have to go and learn all these new coding languages as such. It's very much those analytical kind of thinking skills. And as you said, just you can look and research how to do this. And this is all new.
Let me give you an example. I'm not a quantitative researcher. Quantitative research is a really old discipline. I'm not a quantitative researcher. But I have hundreds of quantitative research models that I have had built for me. I explain my problem. I ask for the most likely model that solves the problem. It does a whole lot of scouting. I then get it to build an algorithm. I plug the algorithm in. I run it. I test it. I run it again, I test it, I run it again, I test it. And once I've done like 9 iterations, I've got something really useful. I then move on to the next one. And that's using AI tool 1, AI tool 2, AI tool 3, and my own common sense. And just a critical eye and a lot of glutathione supplements every night, because otherwise you just...
Yeah, definitely don't underestimate the amount of testing we need. I think with that, my camera's just decided to pop out, but we're right at the end anyway. So we do really appreciate you coming on. I think this was a fantastic talk and very, very interesting from my point of view, who I talk a lot with this sort of level and do a lot of governance.
Brilliant.
So, awesome.
Well, it's been a pleasure. Thanks, Steve.
Yep, thank you so much for coming on. Been really good, and we hope to have you on or speak to you again soon.
Brilliant.
Thank you.
Thank you very much. Thanks.